Hello everyone. For number 23, we're given a function h of t, which is one of those kind of like throwing an object or dropping an object type, almost like a physics related question. And I want to know what would be a realistic domain. So if h of t here is representing the height of the function, so the range is the height here. What's your domain? What are your x values? Or in this case, we're using t. What is t corresponding to? T corresponds to time. Okay, so just by that simple fact alone, we can cross off choice 1, right? Why? Because if t represents time, how can we have some negative time component? Unless we invent some type of time machine, we're not going to go be able to conceptualize -2 seconds. It says it up here. T represents seconds, and also, by the same token, we can get rid of choice 4. All real numbers is like saying from -infinity to infinity, which is even more wrong than choice 1. Let's just type this in the calculator, see what this looks like. Maybe it'll give us a better idea if we're a little unsure of. The calculator's just freezing. What it looks like. So I'm going to type in negative, and it's okay if I'm using x even though it says t. It's just the variable of choice that they're using. You don't actually have to type in t yourself. And if we see what this looks like, the graph's going to be a little large, so I'm going to hit zoom fit, which is zoom 0, I believe. Yep. We see what this graph looks like. So we drop it at some point, and again, it's going to give us the full picture of the graph, but like we mentioned, when we drop something, we're dropping it from right here. Even though the graph is over here, this doesn't exist, negative time. So we're really starting right here. And the domain, where would this end? It would be right here. So it's not going to go below ground after you drop the item. So if we take a look at our table, we dropped it from 144 feet high. I guess we're dropping it off some type of building. And after 3 seconds, it has a height of 0. And what does a height of 0 represent? Hitting the ground. And even though again we see like 4, -112, these don't exist, and that's what the word realistic comes into play here. Even though it exists for the function, you wouldn't have -112 feet when you drop something. So in other words, this function should start at 0 seconds, and it should end at 3 seconds. And looking through the choices, choice 2 exactly models what we're talking about there, from 0 to 3. The word realistic is very important here, because someone might just look at this and go, oh, it's a parabola, that could be all real numbers for the domain, which is true, but if we're talking about a real world problem here, we can't have negative time values or t values for t. Okay, thank you for watching, and hopefully this helped.